Welcome back to Chemistry and Physics on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to have a set of 4 density measurements, and what we're ultimately going to do is determine whether or not this data is precise by calculating what's called a parts per thousand. But in order to calculate the parts per thousand, we're going to have to do a few things first. And one of those things is going to be calculating the average of our 4 pieces of data. Okay, so to remind everybody how we calculate an average, I'm going to go ahead and write this. So what we have to do is we have to sum up all of these values right here. Okay, so again, our first data point is 0.727. Okay, I'm going to add on the next point, 0.737. Again, I'm neglecting the units here, but these are densities, so they would have grams per milliliter units. And then I'm going to add on the next data point, 0.765, and then the last one, plus 0.776. And in an average measurement, I just sum up the values, and then I divide by the total number of values. Well, there's 4 values here, so I'm going to divide this by 4, and that's going to allow me to calculate the average. So let's go ahead and calculate that. So the calculation would be 0.727 plus 0.737 plus 0.765 plus 0.776. And then I divide this by 4, and my average ends up being, if I round it to the appropriate number of digits, it would be 0.751 grams per milliliter. So that is my average. That's the average of my 4 data points. The next thing that I have to do is calculate the absolute deviation of each of these. So the way that I calculate the absolute deviation is I take each individual data point and then I subtract the average that I just calculated. Now in some cases that may come out negative, but since it's the absolute deviation, I just take the positive value of that. So I'm going to have an absolute deviation for all 4 of my data points. So the first absolute deviation would be calculated as 0.727 minus the average, 0.751. Now when I do this, I get a negative value, which is negative 0.024. However, I'm just going to take the positive of that. So my first absolute deviation is going to be 0.024. Okay? Then I'm going to do the next one, 0.737 minus 0.751. And I get an absolute deviation, if I take the positive value of this, 0.014. The next one, 0.765 minus 0.751, the average, and I get 0.014. That one came out positive. And one more, 0.776 minus 0.751, and I get an absolute deviation of 0.025. So these are my absolute deviations. That would be the second thing I would do if I need to calculate a parts per thousand. What I need to do now that I've calculated each individual absolute deviation is I need to calculate the average absolute deviation. So now I have to take the average of all of these numbers that I just calculated. So the way I would do that, I would get the average absolute deviation, and I would just add these up. So the first one would be 0.024 plus 0.014 plus 0.014 plus 0.025. And there's 4 of these points again, so I would divide by 4. So I'm just calculating an average, but of a different set of numbers. So let's calculate what this is. So 0.024 plus 0.014 plus 0.014 plus 0.025. And then I divide that by 4, the number of data points, and I get this number. I get in the calculator 0.01925. Now this numerator right here, because there are actually 3 digits after the decimal point in each of these. So this has 3 digits after the decimal point, this has 3 digits. I can only have 3 digits after the decimal point here. Okay, so my average is just going to be 0.019, and that would also have 3 digits after the decimal point. Okay, and that's going to again have units of grams per milliliter. Again, notice that all of these would actually also have units of grams per milliliter. But again, we were just worried about the calculation. So now at this point, I have an average absolute deviation of 0.019 grams per mil, and I have the average of the original 4 data points that I calculated first, 0.751 grams per mil. Now what I can do is I can do the last part, which is calculate the parts per thousand. And the way that I calculate the parts per thousand is I take the average absolute deviation, which is what I calculated previously, and divide by the original average, and then I multiply it by 1,000. Now notice in this, I'm not calculating a percent value. If I were calculating a percent value, this would probably be a 100. In a parts per thousand, keyword on thousand, I'm multiplying by 1,000. Okay, so if I wanted to calculate this, I would simply take the 0.019, I could throw the units in there, grams per mil, and divide by the original average, 0.751 grams per mil, and then multiply by 1,000. Now in this calculation, 1,000 is an exact number. So this number plays no role in when I determine the number of significant digits in my final answer. Okay. However, if I look at the number of significant digits in each of these, because this is a quotient, this one in the denominator has 3 significant digits. Up top, this has 2 significant digits. So my final answer can actually only have 2 significant digits. But let's go ahead and calculate what that is. So I would calculate it as follows. 0.019 divided by 0.751. I'll go ahead and enter. And then I'm going to multiply this times 1,000, making sure not to do 100, but times 1,000. And when I get an answer, again, it comes out as 25.2996 and so on and so forth. But since I have to round this quotient to 2 significant digits, this would just be 25. Okay? And sometimes you'll even see the units, which are sort of parts per thousand, but 25 would actually be okay in this. But that is my parts per thousand calculation, 25. Okay? Now the ultimate determination for the very last question on this list of questions here at the left is the data precise, yes or no? Well, the rule is that if your parts per thousand that you calculate is less than 20, then your data is precise. In this case, our parts per thousand, since it's 25, is greater than 20. And so we have to conclude that based on this, our data is not precise. Okay, not. Because we got 25, which is greater than 20. And the further you get past 20, the greater the number is, the less precise the data is. The smaller this number is that you calculate, the more precise the data is. Okay? So hopefully this made sense. We went through an entire precision calculation of determining parts per thousand. So in the end, what you have to do is calculate the average of your initial numbers, and then determine the absolute deviation for each of them. Those should all be positive values, all positive values. And then determine your average absolute deviation, and then calculate the parts per thousand by taking the average absolute deviation, divide by the average from up top, and then multiplying by 1,000. Okay? And then if you want to determine whether or not the data is precise, simply compare the number you get for parts per thousand to 20. And if it's greater than 20, it's not precise. If it's less than 20, it is precise. All right, hopefully this video made sense to you. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you very much.